Hello, good afternoon to all. My name is Abhishek Kumar. I am working as assistant professor in Department of Computer Science and Engineering, Artificial Intelligence in IIMT College of Engineering, Greater Noida. Today, I want to present one important topic of data structure and algorithm, that is merge sort. So today we will discuss about the merge sort and its analysis. So first of all, before going to this topic, let's come to the brief outline of what will be the different topics that we will discuss today. So first of all, I will explain about the basic idea of merge sort. As all of you know, that merge sort is an example of divide and conquer strategy. So I will also explain what do you mean by divide and conquer strategy. Then we will go for one example through which we will understand that how the merge sort is working practically. Then I will discuss about the implementation part, that means the pseudo code of merge sort as well as merge operations. Because all of you know that in the merge sort, the most important operation is merging operations. So first of all, we will discuss about the merging operations. Then we will go in the merge sort pseudo code. And then finally, I will discuss about the merge sort time complexity. I think the students who already know about the merge sort, so they know about that in the merge sort, worst case, average case, and the best case time complexity comes to n log n. So how it will come, we will discuss about all these things. So let's come to the topic. So first of all, all of you know that merge sort is an example of divide and conquer design paradigm. So the students who are familiar with the algorithms, so as all of you know, there are basically 5 different strategies that we are following to solve any particular problem. Either we are going for divide and conquer, or we are going for greedy strategy, or we are going for dynamic programming, or we are going for backtracking approach, or we are going for branch and bound approach. So first of all, let's discuss about that. What do you understand by divide and conquer strategy? So in the divide and conquer strategy, we are following 3 different steps. So first, what we are doing, if the problem size is bigger, so we are dividing that problems into different sub-problems. So first part, in the case of divide and conquer strategy, that we are dividing into different sub-problems. And according to the nature of the problem, we are specifying that when we can say that problem will be smaller, or that will be called our termination condition or base condition. As all of you know that in the case of recursive program, if you are writing any recursive program, and in that recursive program, if you are not specifying the termination condition or base condition, that in that case, what will happen, that program will be going the infinite loop and a stack overflow exception will occur. So same thing also here we are doing. That means we are specifying that what will be the size that will be called a smaller problem. So first, what we are doing, we are dividing the problems into different sub-problems. And second steps, that we are concurring the sub-problems. That means we are concurring the sub-problems recursively. Concurring means solving. So what we are doing, we are concurring the problem. We are concurring the problems into different. We are concurring the problems recursively, and finally, final third step is that we are combining the solution. So as all of you know who are familiar with the Corman book, so if you will see in the case of Corman, there is one reference lesson is given for the divide and conquer strategy, that is T of n equal to A Tn by B plus F of n. So what is the meaning of that reconciliation, that T of n equal to A Tn by B plus F of n? It means that T of n is the total time required to solve a particular problem which have n number of inputs. So that problem will be divided into n by b different sub-problems. B will be the size of sub-problems, and A will be how many different sub-problems we are creating. And F of n is the dividing cost as well as concurring cost. So this is the reconciliation that we are following in the case of divide and conquer strategy. So the same strategy we are following in the merge sort. So first of all, what we are doing, that let's assume here you can see if there is a sequence S and that sequence is having n number of elements. So if we want to apply the merge sort, first of all, what we are doing, we are dividing that sequence into different subsequence. So first of all, first condition is that if that sequence is having 0 element or 1 element, that means if in a particular sequence either there is no element or there is only 1 element, in that case we are saying that that problem is smaller. That means that is the case where we have to stop our divide step, and that is the steps that where I have to stop for the divide case. So in that case, what we are doing, that here you can see that in the case of that means if any sequence is having 0 or 1 element, in that case we can say that the problem is smaller and it is already sorted. Otherwise, if a particular sequence is having at least 2 elements or more, 2 or more than 2 elements, so in that case what we are doing, that means we are dividing that sequence into different 2 subsequences. So in the case of merge sort, we are applying very simple strategy, that what we are doing in each, if we have to divide the sequence into different subsequence. So first of all, we are finding the mid value. And to compute the mid value, there is very simple operations, simple mathematical operations, that arithmetic operations that we are following. That means we are finding the low index, and we are finding the lower index of the sequence, then the higher index, and we are adding that and divided by 2. So the same thing, and after that, what will happen, that my particular sequence S will be divided into 2 different subsequence. One will be called S1 and one will be called S2. And in the case of S2, which is the S1 will contain the element from lower index to the up to mid -1. And the second subsequence will contain the element from mid to high -1. The same thing here also in this slide, it is written that S1 contain n by 2. And I am using here the floor. That means floor means, I think all of you know about that, what is the meaning of floor. And S2 contain n by 2 elements of the ceiling. So this is the very simple things that we are doing in the case of divide and conquer. Second thing that we are doing, that we are concurring. Concurring means we are just recursively solving that sub problems. So now you can see initially the problem was S. So S was divided into two different sub problems. One is S1 and one is S2. So now what we are doing, again, we are applying the same strategy on S1, and we are applying the same strategy or same procedure in the S2. And we are recursively solving the S1 and S2. Here solving means that we are sorting the subsequence. Now finally what we are doing, if we can able to sort the S1 subsequence and we can able to sort the S2 subsequence. So finally what we are doing, we are merging S1 and S2 to find the solution of original sequence, that means S. So that is the basic idea that we are following. So now you can say in the next slide, I will show one simple merge sort tree example, so which we can able to understand that what is the meaning of dividing, what is the meaning of concurring, and what is the meaning of combining. So now you can, if you see this 3 steps, so most important steps is concur. That means how we are solving, how we are sorting. That means how we are merging the operations. So that is the one, you can see that is the most important in the case of merge sort. The most important operations is merging operations. So we will exclusively or separately, we will also discuss about that, how we are doing the merging operations in the case of merge sort. So now comes to the very simple example here. If you come to this slide, so I'm taking a very simple example. There is one sequence. In that sequence, there are 8 different number of elements. The first element is 85, 24, 63, 45, 17, 31, 96, and 50. And what we have to do, we have to apply the merge sort on that sequence, and we have to sort that sequence in an increasing order. So now in that case, you can see that if let's assume this is a sequence S. So S is having 8 number of elements. So what was the condition when we can say that the sequence is already sorted? That if a particular sequence is having either 1 element or 0 element, then in that case, we can say that our sequence is already sorted. But in this particular problem, the total number of elements is 8. So that means that sequence is not sorted. So what we are doing, we are dividing that problem into 2 equal half. So first of all, what I am doing, that what we are doing in that case, that we are finding the mid value. Mid value will be low plus high divided by 2. So here you can see, if you are, if all of you know that in the case of sequence or the array, the first notation will be 0 and the last notation will be our n-1. So it will be 0, 1, 0 to 7. So if you'll see 0 plus 7 by 2, and if you are taking the floor, if you are taking the ceiling value, so it will come to the 4. So what we are doing, that means we are dividing the problems into 2 equal halves. So from 0 to third element is coming to the left subsequence, and from 5th to 8 is coming to the right subsequence. So again, now we can see the S is divided into the sequence S is divided into two different, two equal half subsequence. One is S1 that is containing the 4 different elements, 84, 24, 63, and 45. And second subsequence is also containing 4 different elements, 17, 31, 96, or 50. Now you can see again we are doing the same procedure on subsequence S1. So in the S1 also there are 4 different elements. That means it is also not satisfying our termination condition. So again, what we will do, again we will divide that problem. Again we will divide that sequence into two equal half subsequence. So same thing we are doing now again. Sequence S1 is divided into 2 different subsequences. One is 84 and 44, 84 and 24, and second subsequence is containing 63 and 45. Same thing we are doing in the right subsequence, that means S2. S2 is also having 4 different elements. That means it is not satisfying our criteria. So again, what we are doing, again we are dividing into 2 equal halves. One is 17 and 31, and next is 96 and 45. Now again, same steps we are doing in the case of, now you will see we can write this is one S11, and this one we can write as S12. Now also we can write this one as S21, and this we can write as S22. Now we can see here that in the case of S11 also it is having 2 elements. So this is also not satisfying our condition. So again, I am dividing into 2 equal halves. Now we can see one is 85 and next is 24. Same thing we are doing for the next subsequence 63, 45, 17, 31, 96, and 50. So I think all of you know, all of who are listening my class or who are listening my lecture, I think you understand that how many times we have to divide. And now you can see in the last, if you'll see this tree, merge sort tree. So in the last level, because each sequence or subsequence is having only 1 element. So that was our condition. That means if a particular sequence is having 1 element or 0 element, that means that element will be already sorted. So now what we'll do, now you can see here that our dividing the problems will be stopped. So here what we'll do, we'll stop our divide. So here if you see this merge sort tree, so the figure A is discussing about that how we are doing the divide operations in the merge sort. Now comes to the B part, figure B. So in the B is very important. That is our concurring. That means how we are doing how we are recursively sorting the problem. That means how we are doing the merging. So now you can see here that this is a very important topic. This is very important operations of the whole merge sort strategy. So now we can see here that first of all, in the case of divide, we are following the top to bottom approach, but when we are doing the merging operations, then in that case we are following the bottom to top approach. So first of all, we will, because there is one prerequisite for in the case of merging. If you want to merge 2 subsequences, so in that case, the one important condition is that both subsequences must be sorted. If the subsequence will be not sorted, then we cannot apply the merge operations. So here you can see, because in the last subsequence, in the last level of this tree, is already the element is, in each sequence there is only 1 element, and by default, according to our condition, that if a particular sequence is having 1 element or 0 element, that sequence will be sorted. So now we can see that we are doing the merging from bottom to top. So first of all, what we are doing if you'll see the last level of this tree, so we have to merge 85 and 24. So 85 is bigger than 24. So what we will do, we will 24 will become into first place and 85 will become to the second place. Now, same thing we are doing in the case of 63 and 45, because 63 is bigger than 45. So again, what we are doing that 45 will becomes to the first place and 63 will comes to the second place. Same thing we are doing in the case of third. That means we have to merge 17 and 31. So 17 is smaller than 31. So here there is no swapping. 17 will become to the first place and 31 will come to the second place. Now, same thing we are doing for the 96 and 50. 96 is bigger than 50. So again, what we are doing that 50 will becomes to the left first place and 96 will becomes to the second place. So now we can see that initially our last level of this tree was sorted. Now we can see that one more level element that is containing on the you can see in this tree we have, if you are writing a level 0, level 1, level 2, level 3. So initially level 3 all the elements were sorted. Now we can see in the level 2 also all the elements become sorted. Now again we have to do the same approach because this is a concurring is the recursive approach. So again, we have to do the same operations in the case of merging. So now you can see here that if you want to sort the elements on the level 1, so level 1 there will be 4 different elements. How do we are writing a pseudocode when I will write the when I will show the pseudocode, then you can able to understand much better, I think so. So now we can see here that if you want to merge two of this, merge the sequence of this level 2. So in the case of level 2, there are 2 elements in the left subsequence, 2 elements in the right subsequence. Although also same for the 2 element in the left subsequence and 2 element in the right subsequence. So first of all, what we are doing that first of all we are merging the operation, merging the, because 24 and 85 is already sorted and 45 and 64 is already sorted. So now we have to apply the merge operations in 2 different subsequences. So same thing we are doing. We are writing the I for left subsequence and we are taking J for right subsequence. And first of all, again, same thing we are doing. We are comparing 24 with 45. And 24 is smaller. So 24 will come to the first place. And we are increasing the value of I. So now what will happen again 84, that means second I value will become 1. So 85 will be compared with 45. Now 85 is small, 85 is bigger than 45. So again what will happen that 45 will becomes to the second place. Now again J value will be increased. So J value now becomes to the 63. So now again what will happen 85 will be compared with 63 and the value that will be smaller which will come to the upper layer. Upper level. So what will happen? 63 is smaller than 85. So 63 will go to the first level of this tree. Now again there is only one element left, 85. So 85 will be copied. And now you can see the element that is containing on the first level of this tree. All the element is already sorted. So that means 24, 45, 63, and 85 is already sorted. Same thing we are doing in the right subsequence also. So right subsequence, you can see 17 and 31 is already sorted. 50 and 96 is already sorted. So now we have to apply the merge operations in both these subsequences. So first of all, 17 will be compared with 50 because 17 is smaller than 50. So 17 will be go to the upper level and I value will be increased. So now I value will be referred to 31. Now again 31 will be compared with 50 because 31 is smaller than 50. So 31 will also go to the upper level. Now I value will increase. So now you can see in the left subsequence there is no any elements. So remaining 2 elements will be copied on the first level. Now you can see the element that is containing in the first level of this tree, that means 24, 45, 63, and 85 is already sorted. And 17, 31, 50, and 96, both the element that means in the left subsequence as well as in the right subsequence, both the subsequences already sorted. Now, based on this sorted subsequence, what we will do, we will sort the original subsequence. So the same approach also we will following here. So here what will happen, first of all, again, same thing we are doing. That means because for your clear understanding, I am repeating the steps repeatedly. So here again, same thing we are doing. That means 24 will be compared with 17. So 24 is a small, 24 is bigger than 17. So 17 will be go to the first position. Now again, what will happen here? The J value will be increased. So now we can see here the I will be pointing to 74 and J will be pointing to 31. So again, 24 will be compared with 31. Here, because 24 is smaller than 31. So what will happen? 24 will go to the zeroth level of the tree, that means root level. And again, I value will be increased. So now, now what will happen? That now I will point to the 44, 45, and J will point to 31. Now again, same thing, 45 will be compared with 31 because 31 is smaller. So 31 will go to the second position. And again, J value will be increased. So again, 45 will be compared with 50. 45 is smaller than 50. So again 45 will go to the third position. Same thing, again, I value will increase. So now again, 63 will be compared with 50 because 50 is smaller than 63. So 50 will be comes to the root level. Again, same thing will happen. That again, J value will increase. That means now J will point to 96. Again, 63 will be compared with 96 because 63 is smaller than 96. So 63 will be go to the zeroth level, that means root level. And our again I value will increase. So I value will be now point to 85 and J will point to 96. Again, 85 will be compared with 96. 85 is smaller than 95. So 85 will be go to the root level. And now finally again I value will increase. So now in the left subsequence there is no element is there. So 96 will be again copied to the root level. And now you can see the original sequence is become sorted. So now you can see the element that has become sorted is 17, 24, 31, 45, 50, 63, 85, and 96. So I think all of you able to understand that how we can able to do the merging operations and divide and conquer. So I think the students who are listening my class, no one will have doubt in the case of how we are dividing and up to how much steps we have to divide and how we are doing the sorting, how we are doing the merging operations. Now comes to the implementation part. So the first important, because this is the pseudocode written in the Python programming language. So now what I am writing here you can see, first of all, if you see this merge sort, recursive merge sort pseudocode. So here one of the important operations as I was discussing is the merge operation. That means how we are able to do the merging. So first of all, we will discuss about separately. That means what is the pseudocode of merging. Then we will come to the merge sort pseudocode. So now we can see in the case of merge operations, what we are doing, we are defining one function. That function name is merge, and what that function is doing, it is taking two different subsequence. One is S1 and S2, and it is merging in one sequence, that is S. So here this is very simple thing. That means because as all of you already know that there are if we have to apply the merge operations. So merging is only possible when the subsequence is already sorted. So the same thing we are doing. That means there are two sorted subsequence or list S1 and S2, and we are merging in the one particular list, that means S. So first thing what we are doing in the case of merge operations, that we are taking two different indices. One is pointing to S1 and one is pointing to S2. So I is pointing to S1 and J is pointing to S2. To access the different values of S1 and S2, we are taking two different indices, I and J, and we are initializing the I and J equal to 0. That means first initially I is also pointing to the first element of sorted subsequence S1, and J is also pointing to the first element of sorted subsequence S2. After that, we are writing one while loop. So what is the condition that while loop is following? That if we are adding the indices of S1 and we are adding the indices of S2, and if we are adding the value of indices of S1 and index of S2, so that value should be always less than length of S. If that condition is true, So then, if you see that if in a particular sequence, if a particular sequence, there are n number of elements. So in the worst case, that while loop will be run up to n times. So if you will see when we are discussing about it, how much time it will take, merge operations will how much time it will take. So you can see here that in that case, what will happen that if the I plus j, that means both the index, if index of I and index of j is equal to this, so in that case, what will happen? It will be greater than length of s. So here in that case, what will happen that if the length, if the j, that means j means the index of sequence S2. So if j is equal to length of S2, or if I is less than length of S1 and S1I is less than S2j. So in that case, what will happen? Now you can see to understand this. So now you can see here in that case that 17 is smaller than 31. That means here S1I value is 17. S2j value is 31. S1I value is less than the S2j value. So in that case, what will happen? We are taking the Si plus j. So here S1I value is 0, j value is 0. So Si plus 0 means that means S of 0. S of 0, which value we are pointing? We are pointing S1 of I. That means here you can see that in the S1 of S of j, which value is it is going the S1 of I. That means this value is copying to this side. So the same thing here, it is writing very simple. And after that, what we are doing? We are adding the I value to I plus 1. Or if that condition is not true, that means if the S1I value is greater than the S2j value, that means if this condition will not true. So in that case, what will happen? We are coming to the else part. And in that else part, you can see for this first. So here you can see also if S1I value is 85 and S2j value, S1I value is 85 and S2j value is 24. And S1I value is not smaller to the S2j. That means we are coming to the else part. And in that case also what we are doing, we are taking the Si plus j. That means same thing we are doing. Here also I value is 0 and j value is 0. So Si plus 0 will be also S of 0. S of 0, which value we are pointing? We are pointing S2 of j. So S2j value we are pointing in Si plus j. And again, same thing we are doing, j value will get increasing to j plus 1. And how many times we are, up to how many times we are doing? We are doing these operations up to now when the I plus j value will be less than length of s. So in the worst case, we have to do these operations up to n number of times, because length of s will be n. Because in a particular sequence, already it has our assumption that that particular sequence is having n number of elements. So this is the simple merge operation. So if you see and if you find the total cost required for the merging, so it will comes to the order of n, because here it is simple. We are assigning the value in I and j, and assigning is taking only constant amount of time. As well as here, because the while loop, it will run to n minus 1 time. But here also we are doing the simple comparison. We are just comparing the two value, and comparison will also take the constant amount of time. And same thing we are doing, that means we are assigning one value to another value. So this will also, all these operations is primitive operations, and irrespective of only while loop, all other operations will take the constant amount of time. So if you are adding all the time required for this merging operations, so it will comes to theta of n. That means it will take n amount of time. So this is the operations of merging. Now you can see this is one example for merging here. So now we can see there are two different subsequences. One is S1 and one is S2. So here now I is pointing to the third location, and j is pointing to the second location. So now you can see that means if you want to do the merge operations, so which position we have to fill? We have to fill Si plus j. That means I value is 3 and j value is 2. That means we have to fill the fifth position. That means si plus j, that means 3 plus 2, that means 5. So s of 5, which value will point? Now again we'll compare. That what is the value of s1 of 3? S1 of 3 value is 11. And what is the value of S1, S2 of J? S2J value is 10. So because S2J value is smaller than S1I, that means 10 will be copied here. And again, J value will increase. That means this is the case of else part. So the same thing here we are doing. That means now you can see this is our, this is the third location where 11 is present. And in the second subsequence, this is the second location where 10 is present. So in the original subsequence S, we have to fill the fifth position. That means I plus J, that means 3 plus 2. So now you can see here the same thing that I was talking about, that now here you can see in the S, 10 is coming. And now here the J value is increased to J plus 1. Here in the previous case also, I was pointing to the third position. J was pointing to the second location. But now you can, after doing the merging, now you can see the now also here in the S1, I is pointing to the third location, but J, now J is pointing to the third location. Initially, it was pointing to the second. Now second value is already copied into our subsequence, our sequence S. So now again, the J value is increased. So this is the basic idea of merging operations. Now comes to the recursive pseudocode of merge sort algorithm. So this is also very simple, as all of you know, that how we are doing here. Also, we are taking one, we are defining one function. That function name is merge sort, and what it is doing merge sort. That means in the we are passing one sequence S, and S is containing n number of elements, and we after using the merge sort algorithm, we have to sort the element of sequence S. So first of all, we are computing the length because the sequence is having n number of elements. So length of sequence will be n, and we are computing the length and we are storing in a particular variable n. After that, first condition is it is our termination condition or base condition. What was the termination condition? If anyone remember that in the case of merge sort, if the particular sequence is having 0 element on 1 element, that means that sequence is already sorted and we will return immediately. So the same thing we are doing in the pseudocode first. So what we are checking that if n is the length of S. So if the sequence is having either 1 element or 0 element, because here what the condition, if n is less than 2, less than not equal to, here we are not writing equal to, only we are writing n is less than 2. So if the n value is less than 2, so in that case, what will happen? That means our sequence is small. So in that case, we will return. That means our list is already sorted. Otherwise, if a particular sequence is having 2 or more than 2 elements, so in that case, what we have to do, that means this problem, now if the particular sequence is having 2 or more than 2 elements, so according to the merge sort algorithm, that problem is bigger. So in that case, what we have to do, we have to divide into 2 equal halves. To divide the 2 equal half, we are doing very simple thing. That means we are finding the mid, as all of you know who are familiar with Python programming language. In the Python programming language, basically we are talking about 2 different division operations. One is called integer division, one will call float division. So here I am using the integer division, that means n /2. So in the case of integer division, it will always give the integer value. It will not give the fraction value. So here, if what we are doing, because already we find the length, so we are dividing the length by 2. And now after finding the mid value, what we are supposed to do, we have to divide our sequence into 2 equal halves. So now, according to this pseudocode, the S1 will contain the elements from 0 to mid. This is a basic use of slice operations, and slice operations also, who are familiar with Python, they know about that, what is the meaning of slice operations. So here you can see the S1 will contain the first index to mid -1 value, and the S2 will contain mid to n -1. That means first half will become first half will be copied to S1 and second half will be copied to S2. After that, after dividing the problem, and we will do this step will be do up to how many times when the n value will be less than or equal to less than 2. That means up to when either the n will be either 1 or 0. After dividing the problems into a number of different subproblems, so now we have to do the concurring. That means we have to